Hello, this is Team 5. We are ProcuraAI. This is ContractIQ, an AI powered platform for procurement and contract evaluation. So, first, I'll show what we have built since the first demo, then walk through how we engineered it for modularity, scalability, and security. So, in the first demo, we had presented the Figma designs of the UI, and in this sprint, we have implemented it, and now we'll be presenting the actual implementation. So this is our working UI. We select our workspace, go to vendor recommendation mode. The user needs to fill out this form. So let me give an example input. Say we are looking for NVIDIA GPU cloud and industry general or technology should do. And say my location preference is San Jose and I'm looking for three number of vendors and I'm looking for a balanced scoring preference. And this the user can enable if he wants extra analysis. So let's hit get recommendations. Here are our results of three vendors as we asked for, and it has all information regarding the vendors, their website information, the advantages, risk factors, why it is recommended, their location experience, specialization, company size, and also the source citations from where the companies are picked from, and it also for all these companies similarly. So next, moving on to vendor comparison, let's compare any two vendors. Uh, so let me compare Lambda Labs and CoreWeave. Both are from San Jose. Let's compare them. So here are our results, and our AI gets the criteria on which the vendors must be compared, and then it gives a detailed comparison in this table and scores each of the comparisons along with reasoning, and then it finally uh, recommends one of the vendors. So it recommends a CoreWeave. Now we are moving on to the vendor research mode. Here we can do a deep research of a particular vendor from certain sources like Reddit, LinkedIn, or Google reviews. So let us do a deep research on Lambda Labs, that is from San Jose. And let me enable Reddit analysis and Google reviews. And let's research. So here are our results. And it found some subreddits which talked about Lambda Labs and got some reviews on Google too. So there's a positive sentiment from the Google reviews, and there's a neutral sentiment of the Reddit. So this is, and you can go through all these summaries and do your research. So next, the ask question mode and the score contracts mode features are still under development, and they'll be presented in the next MVP demo.
Now, I'll give an overview about the software quality. In designing the system, we incorporated a few software quality principles to ensure that the application is reliable, maintainable, and secure. So, in particular, we focused on modularity, scalability, and security. So, coming to modularity, the system is designed with separation of concerns. So, on the front end, application is divided into independent components such as vendor comparison, vendor recommendation, and vendor research, as shown in the image. Each component manages its own functionality and user interface. So similarly, on the back end, we can see that the system is following a service-based architecture, where core functionalities are implemented as separate services, such as vendor comparison service, vendor recommendation service, and vendor research service. Each service is responsible for a specific task in the system. And at the code level, this modularity is reflected through the use of classes. Each service is implemented as a class that contains its functionality and logic. Here you can see the class and multiple functions belonging to the class. This allows different modules of the system to interact with each other through well-defined interfaces rather than tightly coupled code. So overall, the modular approach we have improves maintainability because individual modules or classes can be modified without affecting the entire system. So the next metric is scalability. Our system is designed to handle increasing workloads by separating heavy computational tasks from main API layer. Operations such as vendor research may require multiple external API calls and require significant processing time. To prevent the API server from becoming blocked, these tasks are handled using asynchronous processing with a Redis backed job queue and workers. So when a user submits a request, the API server places the task in the queue, and background workers process the job independently. So this architecture ensures that the API remains responsive even when many requests are submitted simultaneously. This design allows the system to scale horizontally. If demand increases, additional worker processes can be added to handle more tasks without modifying the core system. So the worker status endpoint, like shown here, confirms that like worker is running, Redis is connected, and jobs are being processed in the queue. The other aspect of scalability is extensibility, and it is achieved through modular architecture. The front end is organized into independent components. Each feature exists in its own field, own folder with separate logic and styling. The same applies to the backend as well with the service-based architecture. So because of this structure, new features can be added easily by introducing a new component without modifying the existing components. So this is about scalability. The next metric is security. Um, so several secure coding practices were implemented to protect the system and its resources. So the first one is secret management, and this is handled through environment variables. So sensitive information such as API keys. Here, like you can see Perplexity API key. It is not stored in source code, rather it is fetched from environment variable. And the second thing that we implemented was authentication. So, like users authenticate through login endpoint, which generates a secure access token, and this token must be included in the request header to access protected endpoints, ensuring that like only authorized users can interact with the system. For example, if we want to call the workspaces endpoint, in that case, like we will have to pass this token, and only if the user is authorized, then only the response will be generated. So the third one is input validation, and it is implemented at both the front end as well as back end levels. On the front end, form inputs such as vendor name, location, and vendor counts are validated before being sent to the backend server. So this prevents like invalid or incomplete data from being submitted. And on the back end, additional validation and sanitization is being performed. This protects the system from malformed requests and helps prevent like common vulnerabilities such as injection attacks or malicious script inputs. Um, so, like we have implemented security through secret management, authentication, authorization, as well as input validation. So this was the demonstration of software quality principles in our project. We have approached the end of our demo. Thanks.